Okay, guys, let us wait for 5 more minutes. Okay, because once I start sharing the screen, I can't allow others to enter. So let us see for 5 more minutes. I think we can start. Yes?
Yes, ma'am.
Okay. Can you see the screen, all of you?
Yes, ma'am.
Okay, so we were discussing about piled embankments and viaduct, and I was asking you guys about viaduct. So, anybody, any idea about viaduct? You can share your if you have heard the name or not. What is a viaduct? Anyone?
Ma'am, Viaduct is a long type of bridge.
Okay, long type of bridge. Any difference between a bridge and a viaduct? Is there any difference?
No idea, ma'am.
Okay, okay, fine. Okay, viaduct, it is correct. It is a kind of bridge, but what it is, there the span of the bridge is small. The length of each span is very small. Okay, so that is a viaduct, and it is used generally in places where the ground is soft, compressible deposit, or where the deposit is of peat soil and all, and generally it is a kind of valley, you can say. So in those small areas, a small valley, we can avoid this soil from using. We can just construct a viaduct, and we can go from this part to another part with the help of this viaduct. Okay, so in soft soil areas, embankment height exceeding the pre-consolidation pressure will give rise to excessive settlement. This can be avoided by means of structural solution, that is viaduct or piled embankment. Then structural solution is recommended in soft ground condition with depth exceeding 15 meter. See, we can use this compaction, dynamic compaction replacement only up to certain depth. If the depth of this soft deposit is only limited, okay. But if the depth exceeds 15 meter, if the depth is more than 15 meter, those solutions like improving the soil by application of surface compaction, dynamic compaction, preloading, these are the methods to improve the quality of the soil. Okay, but when the depth of this weak compressible deposit is more than 15 meter, we should not go for improving the soil. We cannot use those processes. Okay, it will not be economical one. So we can do one thing, we can use structural solutions like construct some kind of structures over that, so as to avoid those areas. Like we can construct viaduct or small bridges we can construct. Okay, to avoid those areas, like for constructing road, suppose you have to use those area where the area is soft and compressible deposit. So we can avoid those areas by constructing some structural by using some structural solutions. Okay, then where height of embankment is more, cost of piled embankment may be higher, and viaduct have to be provided. Okay, that's what we the height of embankment we cannot provide much. in case of soft deposit. That is what. Okay. So I hope it is clear till this much to all. Anybody any doubt? Should I proceed or you have any doubt you can ask? No response means no doubt. Okay, no doubt, ma'am. Tashi. Okay, fine then. Let me proceed to next. So now, what problems can it cause? So this soft deposit, what problems they cause? Let us see here. There are number of problems that may affect properties or services built on compressible ground. Structural damage to foundation and to the fabric of the building, strains or break in service connection to water, gas and electricity, cracks in walls, floors or ceilings of a building, tilting of walls or buildings, differential settlement of buildings, cracks at the junction of buildings or associated structures. So these are the problems we are going to face if we construct something or some structure in those kind of soil deposit. Okay. Since the soil is compressible, if you give load on that soil, there are chances of getting settled. Settlement will be there, and as a result the foundation of the building will get damaged, then the service connections like water pipes, then gas, then electricity wires connections may get disturbed, or this break, they may break the connections, pipe services and all if cracks appear. Then walls and floors will crack. Okay. Generally this occurs in case of differential settlement. Generally, okay, these are the things. This is just a concluding part, that is improvement of the subgrade is integral with and dependent on the improvement of the underlying natural ground formation. Various methods of ground treatment for soft ground can be broadly categorized into structural and geotechnical solution based on various considerations, which included the height of field thickness and compressibility of the soil as well as time and cost. So just now we studied about viaduct and piled embankments. So these are structural solutions. So generally what we do for improving the ground surface, first we have to see if we can improve the soil quality or not. How we can improve the soil quality? Like by application of surface compaction, then preloading, vertical drains, dynamic compaction. These are the techniques where the ground surface is improved, the soil quality is improved, the shear strength is increased, bearing capacity is increased, pore pressure is reduced by various techniques. Okay. But these techniques of improving the soil can be used only if the depth of the weak deposit is up to certain limited depth. Okay. If suppose the depth exceeds very much, like the limit is given according to IS code, the limit is given as 15 meter. So if the depth exceeds to that, then we cannot go, or we should not actually go for improving the soil quality. Okay. Rather, we can do one thing, we can go for structural solutions. Okay. We should go for structural solutions, like we can construct stone columns, we can construct, then we can construct viaducts or embankments, piled embankments over that. Okay. So as to avoid that part of the ground. if possible. Okay, always we cannot go for structural solution, and also always we cannot go for geotechnical solutions. So generally the ground treatment for soft ground is classified into structural and geotechnical solution, and this will depend on the type of site, type of the depth of the weak deposit, and also the time and cost required. Okay, depending on these things we should take the solutions. So I hope this topic is clear to all. In case you have any doubt, you can ask. Any doubt you can ask, or anything you want to share, you are most welcome. No doubt, nothing to ask, nothing to share. Yes or no? Are you guys there, or you have just connected or left?
Ma'am, no doubt.
No doubt. Okay. Okay, fine. Then I will proceed to next topic, which is dynamic compaction. Just wait a minute. So now here we will study in details, little details about dynamic compaction. So all of you are well familiar with dynamic compaction now. Still, let us see. Dynamic compaction is a ground improvement techniques in which a drop weight is used to densify the soil and fill materials. The drop weight is typically made of steel and is lifted by a crane and repeatedly dropped onto the ground surface. The vibrations that are resulted from the repeated drops are transmitted below the surface, which improves soil at depth. These drop locations are generally located on a grid pattern. The subsurface condition and foundation loading and geometry determine the spacing of the grid pattern. So dynamic compaction, it is the process where a heavy load is dropped into the ground surface. And I have already told you, when we drop such a heavy load on the ground surface, vibrations are created, or energy waves we can say. Okay, energy waves are created and they reach to the deeper inside the ground, and the soil gets compacted, and this process of dropping the weight into the ground is done in grid pattern, and the spacing of the grid pattern, it depends on the geometry of the structure, geometry of the structure, and foundation condition, and subsurface conditions also. Okay. Let us see an image, it will be more clearer. Just wait a minute, okay? Can you see the image, all of you? Is the image, some image is visible to you? Yes, ma'am. Okay. Okay. So you see here, dynamic compaction is done in this process. This is the heavy load that is, and it is made of steel. Okay. This load is lifted with the help of this crane, and then it is dropped into the ground, and it is dropped in a grid pattern, I have said. So see here, grid patterns are shown. These are called grid patterns. Okay, that is, if we join four points like this, suppose I have taken this point, then this, if we join like this, it will form a square or rectangle. Okay, four sided figure it should form, this one. Okay, this is called grid pattern. And this spacing, the space between the grids, suppose this is one grid, this whole like whole flex thing is shown, it is not whole. Here compaction is done, the drop is put here, and this spacing between the grids, the spacing between the grids, it will depend on the type of foundation load you are going to apply, and also the subsurface conditions. Okay, then here another image we can see, the pounder means the load, it is dropped here with the help of this crane. Similarly, same thing, the load is lifted and it is dropped. Then what happens, the wave energy, it travels in this direction like this, the dotted lines we can see. The dotted lines generally denote this wave, and this sorry, energy waves. Okay, energy waves are shown with the help of these dotted lines. So here are some points are marked, 1 2 1 2. So suppose the load here is put in the yellow part, that is 1, it is marked with 1, and the energy waves it transmits in this way, and then this portion gets compacted or densified. Okay, here also in part 2 we can see the load is dropped here, and the wave and the energy waves or the vibrating waves, vibration wave, it travels in this along these dotted lines, and these dotted lines for this part 2, and then this much portion, these portions of the soil gets compacted. So like this it is done, then again it will be dropped here. Here this upper portion, brown color portion is shown here, it will be dropped, and thus like this the process will be repeated, and the whole portion or the whole site will get compacted. Okay, is it clear, the diagrams? Any doubt? Is it clear to all? Okay, fine. So next, see here, dynamic compaction utilizes the dynamic effect of high energy impact which are caused by the drop weight of steel. These large steel weighs 15 to 40 tons. That is the weight of the steel drop, or the pounder we can say, which is dropped into the ground. The weight is this one, 15 to 40 tons, which are dropped from a height of 10 to 30 meters. So generally this weight, the pounder of 15 to 40 tons are lifted with the help of crane up to a height of 10 to 30 meter, and then from that height the pounder is dropped into the ground. So you imagine how much vibrations will be created, how much energy waves will be transferred, just imagine. And then what will happen, okay, we'll go to that the next part. Then the actual purpose of this technique is to transmit high energy waves through a compressible soil layer to improve geotechnical properties of soil at greater depths. Dynamic compaction is normally associated with an intensive procedure which undergoes in situ testing to verify that the specified improvement has been achieved. So, we will repeat this process, we'll keep on doing this process unless the required improvement is achieved. Okay, that is what. Then dynamic compaction is applicable to all types of granular soils. This technique is particularly well adapted to the following soils. So in this kind of soil generally this process of dynamic compaction works very good. Okay. Otherwise, so we can use for any or all types of soil that is granular soil. Okay, so non-organic soil, non-homogeneous field, made ground, that is area of land that is man-made by reclamation of marshes, lakes or shorelines. In this kind of areas, reclamation areas with variable characteristics, also where underground obstructions are present, then soil with large air voids such as refuse dams and poorly filled grounds. So dynamic compaction is effective in both saturated and non-saturated soil. Typically, this technique should not be carried out within 15 meter of existing services and 30 meter from existing buildings. So I told you that the vibration will be made when we drop such a heavy load from such a height. Huge amount of vibrations will be created, and as a result if there is any adjacent structure that will get disturbed. Okay, there are cracks and all may appear, so this thing should be noted. Okay, spacing part will continue in the next class. Till this much, anyone, if you have any doubt, you can ask. Otherwise, let's stop here for today. Any doubt till this much? Dynamic compaction meeting is going to end within 5 minutes. Any doubt till this much? Anyone? No. Okay, fine. Then let's stop here for today. Next, we'll connect in next classes. Attendance, I have taken, I have already marked. Okay, you guys can leave now. Okay, thank you.